randomization and weighted probability distribution in data science. I mean, randomization is not a data science and neither weighted probability distribution in data science. These are pure mathematics terms. But nowadays, the maximum thing that is used in whatever the program we are developing. So mathematics maximum, it is going in data science. Means it is used at other places. But the biggest customer of mathematics nowadays is the data science. Okay, so the discussion is about what is a random number, how we generate the random number, what is seeding, what is random state, and then we will use it to first make a random selection from a list, and then list should be a weighted probability distribution. So this is the full story. Okay, so random number means any number we generate. So if I say I want random number between 1 and 100, then anything should come. Then again if I say I want random number between 1 and 100, then again it should not be predictable. Random means it should not be predictable. So prediction should be 0, means no one should be able to predict it. So how number are, when we say that we need a random number, then random number generation, the algorithm, it should be based upon something which is not fixed. So if I say that like random is a Python library, means package, and it has a function that is called random. So if someone calls the function, now random function would depend upon something that is variable. That's why variable in the sense that it should not get repeated again. That's how it would generate something that will be new, like the time now. The time, what is happening, will never be get repeated, not possible. Means if to now this much microsecond and then second and then minute and then day, year, this is never going to come back. So generally the randomization algorithm, when it generates a random number, it is dependent upon the system. Now system typically it gives the time, system time as the a base to generate a random number or anything what it thinks that it is unique and it is never going to come back. Means it may have some algorithm which is generate based upon something, but best thing is the system time. So this is called seeding. Seeding in the sense based upon what we are generating a random. Okay, once random number is generated and based upon this algorithm generates a random number this. Now this algorithm, based upon this algorithm the random number this. Now if I ask this algorithm to generate a random number again, whatever the output came in the last calculation, based upon that it will generate a new random number. Now if I ask this to generate a random number again, whatever calculated in the previous output, based upon that algorithm would generate the next number. So this is how random number generation happens. So it starts from a seed, means the initial value. From the initial value, then a fixed algorithm works. Now, if I set an initial value on my own, then every time I generate a sequence of random number based upon the initial value, then again same initial value, sequence of a set of 10 numbers. So initial value, that is a seed, 10 numbers, then again same initial value, 10 number, again same initial value, 10 numbers. It should be, the sequence should be constant. In Python term, the list should be equal because its length is equal, type is equal, and all are same. So this is seeding. Seeding in the sense setting the initial value. Based upon that, it would generate a random number and then based upon the output of the first random number, what a random number is generated, the next random number. And it keeps on doing till the number we want, how many we want. So if initial value is same, then the sequence would be same. So this is how we can kind of, we make it predictable. Like I am writing an algorithm and we want that it should work in a fixed fashion. Then we will make it seeding. It will start seeding with something. Then after that, whatever number it generates, it is same number every time. So we can test our algorithm. It's a crucial point. Or if I want random number to generate from a seed that is from system, then I can say null, nothing. Then like random.random and nothing, empty bracket, empty parameter. So it is none, and it will go to system to start the initial value. Otherwise, whatever seeding, so random.seed, whatever we provide, that will become the initial value. That is one thing. So one time, if I set the seed, then based upon the seed, every time it generates. What about every time I want things to be generated with different seeds? Okay, so problem is if I set the seed and generate something, and then full means it will change the kind of seeding. What I'm trying to say is that I have an algorithm. I have many set of algorithms. In one algorithm, I change the seed and then calculated all the random value. If I call the another algorithm, then whatever the seeding we have done, so that will become input to the next algorithm also. Means all the algorithms will be dependent upon the first algorithm what we initially set the seed. This is I don't want. Means what I want is, so we talked about randomization, seeding. Now we are talking about independence in the randomization. So if I have 5 algorithms and 5 algorithms should work independently, then if I set seed in any algorithm, then all algorithm will be kind of cluttered with the whatever we have nonsense we have done. Nonsense in the sense that for all algorithm it is nonsense only. Whatever nonsense we have done in the previous algorithm, all will get suffered. What about local seeding? All algorithm will have local seeding, and it should not be dependent upon. It should not get become dirty because of the other algorithm. So the obvious choice is viewed. So we can think that we set the class variable seed and all same class is being used. So obvious solution is we need to have an object. So for each algorithm we need to instantiate one object, and that object we will seed, and once the algorithm is over, object is over. In next algorithm, even if I use random, then it is not dependent because we did everything through object. So that is called random state. In NumPy it is called random state, otherwise it is random, capital R. So this is a random. So random is a kind of a class. If I instantiate, then I seed, then through random only I have to take back all the numbers, and that will be local to the object what we instantiate. Or in the NumPy, random state is the class. If I instantiate with some seed, then the instantiation I have to, whatever we have instantiated, I have to use those methods to take out the random number. But if I instantiate the random state again, then independent. So all algorithms can have their own random state instantiated and then independent of each other. So this is the way. So we talked about random, we talked about seeding, and then how we can make kind of a context-wise, that whatever randomization we are doing, for each context it would be different. So it is possible with the random state class object. So every random state class is state, it's a state, it maintains a state. And once we initialize the random state object, then random state methods that I use to get choice or to generate any random or sample state whatsoever, it will be based upon that state of that particular object, not global. Okay, so story is up to here, and now how we can use this randomization. So randomization means we get a random number. So suppose that I have 10 numbers. I have to choose from 10 numbers, 1 to 10. Numbers are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Out of 10, I have to choose a number, and every number has equal probability to be chosen. So that is the idea. Now what I would do is, I'll say random number that please generate one. So random number, it did seeding and everything, and it generated a random number. I can say, I can normalize is to the whatever number it generates, then I can normalize it to be in a kind of in a close bracket of 1 and 10. It's possible to normalize it. So once it is normalized, so that index in the list, so list starts from 1, means consider it starts from 1, then 1 to 10, then whatever random number it generates, 50,000, I normalize it to come within a close bracket of 1 and 10, then whatever number it comes, then that index I would pick, and I would say that this is the randomly selected number from a list. We also call it choice, means this is the choice. So random number generated a number, and through that number, this particular entity in the list, this particular item in the list got selected. We cannot do anything. So this is randomization and making a choice in a list based upon the randomization. Now I cannot say that whoever will be selected, because everyone has equal chance. So number 1 to 10, if I try 10 times, then it should select each number once. If I try 20 times, then it should select each number twice. So that is the concept of randomization and the making a choice in the list. So this is up to here. Whatever we are discussing in the during this session. So few things are new that has never been. Means generally you will not see anything. Okay. So our idea is to make things acquainted. That is the one thing. And second thing is that new things should come, because things should grow. Because we are not here loudspeaker that whatever is being invented by someone, and then we are repeating same thing. So whatever we are talking, we are adding something. So as per the discussion, we are filing disclosures for each video, whatever we are talking. Now we'll proceed on the weighted probability distribution. Weighted probability, WPD. So weighted probability distribution. Now suppose I have 6 numbers. I have 6 numbers. 1, 2, 3, 4, 5, and 6. Now, the number 6 has a weight of 0.5, half, and others have weight of 0.1. If I have 6 numbers and everyone has equal weight, equal distribution to be, equal chance to be selected, then everyone is 1 by 6. So if I put in a sequence 1, 2, 3, 4, 5, 6, and everyone has equal chance to get selected, then it would be one getting any number to get selected in 1 by 6. Now the 6th number 6 has chance of half, means 0.5. Other are 0.1, 0.1, 0.1. So total is 1. This is what is expected. Now through randomization, how I would select from the weighted probability distribution? That is a big question. And whatever I could do, that I would elaborate, but this is a matter of heavy research. That how with the weighted probability distribution, how we can proceed in a way that we shall be able to pick from a sequence of items where each item has different probability. That is weighted probability. Everyone's weight is different. There can be many scenarios. 3 scenarios I'll talk. So one scenario or four scenarios. One scenario is that 1, 2, 3, 4, 5 slots I am creating, and 6, since it carries 0.5 probability, 5 times this guy, it will be repeated 6 times. Okay, so 1, 2, this is not available anyway. 1, 2, 3, 4, 5, 6, 6, 6, 6, 6, 6, 6, 6, 5 times. Now sequence is ready. Now through randomization, we are going to pick any one. So half chance is there. So if I try 10 times, then 5 times 6 should get selected. This is one way. Second way is that how many times, if I say that 6 is twice, 6 is twice. So if everyone is now 6 is double, 6 is 5 times to the other guys, and 6 is twice. Okay, so other guys would probably, they will come to 0.05 and then it will come to 0.3. Okay, I believe something like this. So earlier they were 0.1, so 0.05, 0.05, 5 times it will come to 0.25, and then 5 times 5, something like that. Means if it is 6 is double of whatever is the criteria. Means the idea is that any number can be repeated, or 1 can be repeated, 2 can be repeated, and 3 can be more times. But with some mathematics, we will set each probability in a way that total addition would be 1. So that is the scenario. So this is another scenario. So here, then again, based upon their probability, we will multiply it as many times in the sequence. So if I have 6 unique number, but depending upon their weight, it may grow up to 10, 12, 20, whatever. Now we will select from the randomization, we will select a number, and the number which is repeated, and so the chance to get selected is more, and number which is high weightage. So if number has a high weightage and it is repeated also, the chance of getting selected is more. So this is one scenario. So another scenario can be that non-replacement. If I select a number, if I select 6, then I take out the 6, that it is not required next time. And then I select from the others, whatever are available. So this is another scenario, that is we will kind of, we cannot repeat it, non-replaceable. Okay, this is second scenario. Now we'll come back to the same question, weighted probability distribution. So the first main thing what we saw was whoever has more weight, we duplicate it, and then we try to find the random index, and then we try to get whatever it is. Second is that suppose 6 is not at the end, 1, 2, 6, 3, 4, 5. This is how it is adjusted. Now then one approach is that wherever 6 is there, then we'll expand in 5 and then we'll make it 5, 6. Another approach is cumulative sum. Means from the beginning we'll start adding from the previous. So first is 0.1, second will be 0.2 because 0.1, 0.1. So 1, 2, 3, 6, 4 and 5. So 1, 2, 3, 4, 5 is 0.1 probability and 6 is 0.5 probability. So 1 is 0.1, 2 is 0.1, 0.1, 0.2, 3 is 0.3, then 6 is 0.8, then 0.9 and 0.10. This is cumulative. So we will make it cumulative. Now through randomization, I'll get, now I won't get the index. Earlier we were getting the index. Now through randomization, I will get the probability between 0 and 1. So suppose probability comes as 0.3. Then from the beginning, we'll start checking that where it is 0.3, because through randomization, we are not selecting the index. We are selecting the net probability. So through randomization, I get a number between 0 to 1, that is 0.3. So I would say the number which has 0.3 as the weightage, so that should be selected. So from the beginning I'll start, so 0.1, then 0.2, then 0.3, okay. It should be whatever the random we have got, the number should be bigger to it, then 0.8. So number 6 would get selected. Okay, so idea is the next try what we are making, whatever the number we have in the sequence, everyone has a weightage. From the previous weightage we keep adding cumulatively so that the last guy's weight will become 1. So if I have 1, 2, 3, 6, 4, 5, 6 has 0.5 as weightage and rest is 0.1, then first we'll have 0.1, then next will be 0.2, third will be 0.3, then 0.8, then 0.9 and 1. Now through randomization, we will try to get the actual probability, actual weightage, not the index in the whatever we tried with the first approach. So if it comes as 0.3, then the guy who is 0.3 weightage, that should be selected. So how we select is, we'll start from the beginning and whoever crosses the 0.3, okay, that will get selected. Okay, so if so first, second, third is not crossing 0.3. 4, that is 6, is crossing the point. So 6 will get chance maximum time. Now if from randomization, if I get 0.2, then third will get selected. If from randomization, if I get 0.9, then 4 will get selected. Number 4. So 1, 2, 3, 6 and 4 will get. This is another idea. So two ideas we discussed. One is that we kind of duplicate who has more weightage and then make a big sequence. From randomization, we pick the index and we take out. Since it is more in number, so getting the chance is more. Second solution is from randomization, we pick the probability between 0 and 1, not the index. And here the probability wise we make a cumulative summation and then we check the probability what we have got, it matches with. Okay. Then third thing what we think is, whatever the cumulative probability we are making, prior to that we sort it. Okay, so the guy who is at the maximum weightage would go to the end. So that means anyway, so if I select the probability at random, so if it is well distributed, because it is well distributed, it will come from 0 to 1, then these guys would get chance. So who has lower probability would get chance to get selected in kind of a uniform manner. So this is one thing. But here also duplication is repetition is possible, and repetition and non-repetition, that chance. Like if someone has more weightage, more in number, or anyone has more in number, then how we'll do, and should we take out that? If 6 got selected, then should we take out 6 completely or all the 6 if it is more in number? These many scenarios that we are thinking. Now it is open to the kind of any developer that he can think more scenarios. So we talked about how we generate a random number algorithm, how it generates a random number. It is based upon some initial number, and that is typically provided by system, that typically from the system type we can seed and get the initial value, and then a sequence of number is generated. We can make context wise also, creating the random number, sequence number that comes in the random state. And then we saw the probability, weighted probability distribution, and where either we pick from the index what we are doing, or picking from a sequence. So once we generate a sequence, once we have a list of numbers, through that we want to make a choice of a number. Then through a randomization, whatever random number we get, we make an index and we take it out. And in the weighted probability distribution, if someone exists, has every item in the sequence to be chosen upon or to be selected from, has a different weightage, then we can multiply so that index would select that number more. Or we can create the cumulative sum and then we from the randomization we don't get the index, rather we get the weightage which should be selected, and we start matching. Now, before doing the cumulative sum, we can rearrange as per the sorting order. Then for everything, we can make option that if some number gets selected, then it should be taken out of from the list if it is getting selected. For item, if it is getting selected once, there is a repetition of a number, that is also possible. So many. Okay, so it should be well tried and it can grow more. This is what I expect.